Now I will finally be setting up the export system. To start the system, I'll want a couple of object merge nodes. I'm going to use these nodes to get information from our rig. These nodes will be feeding into a KineFX ROP Fbx output. I'm going to be using the character output to export the character. This export will only be for the character rig, and I'm not going to add any animation for the character at this point. So I'm going to start with a more basic version of this export, and this would be the export which I'd be using if I was exporting to Unity. The version of the rig that I'm going to be exporting to will be the rig skeleton. For our other node, we'll need to look at our weighted mesh. Although in this case, this is not the mesh which I'll be referring to. I'll be referring to the poly-reduced version. In a fully fledged rig, I'd have different levels of detail, and I would be exporting multiple versions of this rig. The first object merge will reference our poly-reduced node. This will give us the lighter version of the character's mesh. This node will feed into the first input of the Fbx character output node. The next object merge will refer to our skeleton. This will feed into the second input. The second input will contain the skeleton for the Fbx character. The final input would be for the animation. We do not need any animation when we're exporting the character, and in many cases I prefer not having animation on the base character. It is possible to put a default animation here, but I will not be doing that currently. The next thing to set is the Output Fbx file. I'll go to my HIP directory, and then I'll create a new folder, and I'll call this folder FBX. I'll call this export insect rig 0. I'll specify that it is a Unity export. I have not entered the extension. The extension should be FBX. That should be all that is needed to export the character itself. I can then save to disk. So the next thing that we want is our animation. Once again, we'll get the animation output null that we've placed at the end of our rig. So I'll start by getting a ROP Fbx animation output node, and then I'll get an object merge node. And in the object merge node, we'll reference our animation out. This node will feed into my Fbx output node. I can now specify the output file and directory. I'll be exporting this into my Fbx directory. I'll use a similar naming to that of my character. However, in this case, I'll put an animation name in, and the name here will be test. This naming format is not particularly good. It would be better if I had version numbers for both the character and the animation, but we can ignore that for now as this is primarily a test. So now we have the name for the file. And then we have a lot of options in this node which we can set. And we can set a lot of these values. However, I'll need to change this clip range value in order to be able to set them. This would enable us to set things like the frame range. There are also options like the clip name, which would give us the specific name for this animation. We will not be setting any of the values in this node, however. The values in this node are rather messy, and there's a much cleaner way to set them. And that would be to use the configure clip info node. Using this node is just neater than setting these values in the Fbx itself. It will also allow you to define separate clips in a single animation. An easy example for this would be defining a jump animation, where you have a jump start, a jump in the air, and a jump landing animation all together. You would want all of these to be part of a single animation, but you want to be able to separate them when using them in a game engine. So in this, I'll enter the clip name, which will be test. I'll have the sample rate. By default, this is linked to the scene's frame rate. The default frame rate is for film, which is 24 frames per second. We can change this if necessary. The clip range is the same. We'll get this from the project's frame range. The same will apply to the source clip rate and to the source clip sample range. We can also set behavior like looping and mirroring. This is something which I generally prefer to set in the engine. I'll then duplicate this entire setup. In this version, the mesh will remain the same. However, instead of the skeleton we're currently referencing, we're going to refer to the root skeleton, which is our skeleton with the root bone. I'll then change the name of the export to Insect 0 Unreal. I'll then want to update the object merge for the animation out as well, and instead of referring to the animation directly, I'm going to refer to this null over here where we've set our root motion. I've not renamed this null properly, however. I'll rename this null to animation root out. The object merge will now refer to this animation root out node. I'll then update the name for the animation export, and this will be my insect0 test Unreal. I can then save these files as well. And that should be it for the export system. I'm then going to test these exports in Unity. I'll now be importing these files into Unity. I've got a very ugly sandbox scene which I'm using for testing. I'll drag and drop both the FBX files into Unity. This will be the character file and the animation file. I can then take a look at the files in Unity. We'll start with the character file. I have my character imported, and it does have the basic materials attached. I do not really want to use FBX for the actual materials, as FBX is not a good material transfer system. It generally will only transfer the names of the materials, the colors, and it will allow us to import the textures. If we look at the remap materials, we'll see that no Unity materials have been attached to this rig. I can extract the materials. This will create materials based off the Houdini settings. However, this is pretty much limited to the name. If we had textures attached, we could also import those, although it will not import all textures. Basically, we're importing the materials name and the base color attribute, and we can build our Unity materials based off that. I can now take a look at my animation, and when the animation is selected, we'll see that nothing shows up for the animation. The reason for this is that Unity requires us to create an avatar for our characters. This avatar is a map for the rig that is used for retargeting. So I'll create an avatar for my original rig. I can then look at my test animation again. I can drag and drop my avatar into the playback window, and we should now be able to view the animation for the mesh. I can now bring my insect model into the scene. I'll add a controller for this character. I can then bring my animation into this controller. I can delete the animation controller default, and this will make my test animation my default animation. I'll then make sure that my animation is looping, and I should now be able to play the animation within Unity. So I have my character imported into Unity, and I'm able to apply the animation to the character within Unity. We have the basics for a pipeline set up now. In the next video, I'm going to make sure that this rig has an easier interface to work with.